From tree dweller to ice age hunter, how early primates became the apex predators of the Pleistocene. 20,000 years ago, something that should never have existed was ruling North America. A bipedal ape with a brain barely larger than a modern chimpanzee's was hunting animals 10 times its weight across frozen steppes. No fangs, no claws, no armor, just intelligence and persistence. Most evolutionary histories treat this as inevitable, the gradual march toward human dominance. That version is comforting, but it is also completely wrong. I'm going to show you how an accident of climate, a cascade of predator extinctions, and one desperate adaptation turned our ancestors from tree-dwelling scavengers into something that could stand alone against the megafauna and live to tell the story. If you've watched content about Ice Age giants before, you probably want to stick around for how this all connects. And if you're new here, I'd love to know in the comments what drew you to this era. Are you here for the mammoths, the predators, or the mystery of human survival itself? Subscribe now so you don't miss the full picture of how these worlds collided. Wait, this part is critical, so give me your full focus for a moment. Before I walk you deeper into this story, you need to know that every mechanism, every trigger, every turning point in how primates went from forest dwellers to apex predators is documented in exhaustive detail in our complete guide available in the description and in the pinned comment at the top. That guide breaks down the behavioral shifts, the climate patterns, the prey populations, all the deep mechanisms that created this transformation. It's a paid resource, but it's where the actual data lives, and it's built specifically for people who want to understand, not just watch. Now, let's reset. 7 million years ago, before any human species existed, before ice ages dominated the planet, before North America looked like anything we'd recognize, our earliest primate ancestors were spending most of their time exactly where you'd expect them to be, up in trees. They weren't dominant. They weren't impressive. A troop of modern chimpanzees would have killed them. These creatures weighed less than 50 pounds. They couldn't run faster than anything hunting them on open ground. Their canine teeth were small compared to other primates of their era. On paper, they were evolutionary failures. But trees don't last forever. Between 7 and 4 million years ago, the world's climate began cooling. It was slow at first, so slow that no single generation would have felt it as a crisis. But across millennia, the forests shrank. The canopy gaps widened. Fruit-bearing trees became less reliable, spacing themselves further apart. Our ancestors faced a choice that evolution doesn't actually offer a choice for: adapt or vanish. Some primate lineages stayed in the shrinking forests. Many of them did vanish when those forests finally collapsed. But one population started spending more time on the ground. They walked upright on their hind legs when crossing open spaces. It wasn't efficient. Bipedalism is actually one of the worst ways to move on flat terrain if you don't have the anatomy for it, and our ancestors didn't yet. They were slow. They tired easily. But it had one advantage that no other climbing primate possessed. It freed their hands. Once your hands aren't needed for locomotion, they become tools, not weapons. Tools, sticks to dig, stones to crack open bone marrow, bark to carry water. This isn't the path to becoming a hunter. This is the path to becoming a scavenger, something far more common and far more necessary in a world where predators were already filling every hunting niche. For millions of years, our ancestors scavenged. They followed lions and saber-tooth cats, waiting for them to abandon kills. They used rocks to smash open bones that other predators left behind, eating the rich marrow inside. It's a grim existence. It's also brilliant. It keeps you alive without competing with animals far better equipped for actual hunting. Scavenging anthropologists call this pattern obligate scavenging in the academic literature. For our ancestors, it was just survival. The first evidence of stone tools appears around 3 million years ago in Ethiopia. These aren't weapons. They're hammers and scrapers. They're designed to process already dead meat, The fossil record shows our ancestors were living alongside packs of hyenas and wild dogs and saber-tooth cats, all feeding on the same kills. Our ancestors weren't dominant. They were participants in a system that tolerated them because they could crack bones that predators abandoned and extract nutrients that would otherwise rot in the sun. This scavenging phase lasted nearly 2 million years. 2 million years of learning which bones held marrow. 2 million years of timing your arrival at a kill site. Too early and the predators still guard it. Too late and the meat spoils. 2 million years of understanding animal anatomy. 2 million years of teaching the next generation not just what to eat, but how to process it. That's not random. That's knowledge accumulating. That's culture forming. That's the foundation everything else would build on. Part 2 continues deeper into the climate shifts that would shatter the scavenging equilibrium. Around 2.5 million years ago, the climate shifted. Not gradually, not gently. The Earth's orbit wobbled in patterns that scientists can measure and predict, and those orbital cycles locked into a rhythm that pulled global temperatures downward. Ice sheets thickened across the northern continents. Monsoons weakened over Africa. Grasslands that had supported dense herbivore populations began fragmenting into isolated pockets. The abundance that had sustained the scavenging strategy was disappearing. When herds shrink and scatter, kill sites become rarer. Predators travel farther between meals. A corpse no longer guarantees a congregation of carnivores that can be followed and robbed. The margin of survival narrows. Your population, which had grown comfortable depending on the leftovers of other hunters, suddenly faces a choice: adapt or starve. This is when something shifted inside the primate lineage that had learned to scavenge. They didn't wait passively for predators to make kills anymore. They began killing for themselves. The evidence is unmistakable in the archaeological record. Tool marks on bone change. Cuts begin appearing that could only have been made before a predator fed on the carcass. The sequence of butchering shows planning, not desperation. They were selecting specific animals and targeting specific body parts. They had become active predators. The transition wasn't instant. For perhaps 500,000 years, hunting and scavenging coexisted. But climate pressure intensified the advantage of hunting. Groups that killed their own food ate more consistently. They raised more offspring to reproductive age. Scavengers were gradually outcompeted by hunters within the same lineages. By 2 million years ago, the Homo lineage, which had split from the Australopithecines, was committed to hunting as a primary subsistence strategy. This shift changed everything about how their bodies developed and how their minds worked. Hunting large animals requires planning. You cannot kill a buffalo or a wildebeest through accident or impulse. You must anticipate where the animal will go. You must understand its behavior. You must coordinate with others. You must make decisions in real time when the plan contacts reality and inevitably falls apart. This requires language, not the basic alarm calls that chimpanzees use, not the territorial songs of gibbons. Language that can describe abstract concepts, language that can encode sequences, language that can transmit knowledge about things that aren't present. Hold on, I need to pause here for a moment, because this is where the neurobiology becomes relevant. The hunting lifestyle didn't just change behavior, it restructured the physical architecture of the primate brain. Groups that hunted cooperatively needed larger frontal lobes to manage planning and impulse control. They needed expanded language centers to coordinate complex group actions. They needed enhanced theory of mind, the ability to imagine what another individual was thinking and planning. These aren't small tweaks. These are fundamental reorganizations of neural real estate. Now, if you want to understand the complete mechanisms of how hunting behavior actually reshaped the evolution of the human brain, the specific neural circuits involved, the role of fat and protein in fueling larger brains, how tool use itself drove selection for manual dexterity and cognitive sophistication, that's where my detailed guide on this entire subject becomes essential. It's available in the description and pinned in the top comment. It covers the neurological transformation in depth, layer by layer, going far beyond what we can explore here. It's a paid resource, but it's where the full picture comes together. What matters for now is that the connection between hunting and brain expansion is real and measurable. Homo erectus, which emerged around 2 million years ago, had a brain roughly twice the size of Australopithecus. That's not a gradual drift. That's a response to intense environmental pressure. Hunting large animals demands cognitive machinery that the earlier scavenging lifestyle never required. The ecological niche these early hunters occupied was dangerous and marginal. Predators outnumbered them. They lacked the speed of cheetahs, the strength of lions, the natural weapons of hyenas. What they had was coordination, planning, and an ability to learn from failure that no other predator possessed. They threw rocks and sharp sticks. They drove animals into swamps or off cliffs. They worked in small groups using terrain as an ally. Over hundreds of thousands of years, this lifestyle sorted for individuals with better impulse control, better communication, better memory for complex information. Natural selection doesn't care about consciousness or intention. It cares about reproductive success. Hunters who planned better had fuller bellies. Hunters with fuller bellies had healthier children. Those children inherited the genetic basis for the cognitive traits that had made their parents successful. The pressure was immense because the stakes were absolute. Failure meant starvation. Success meant survival and the chance to pass on genes to the next generation. By the time the last ice age descended on the planet, roughly 23,000 years ago, human beings had already conquered nearly every environment on Earth. They lived in tropical forests and coastal marshes. They hunted across open steppes and tundra. They survived in deserts. The same capacity for planning and learning that had evolved in Africa had proven remarkably flexible when applied to radically different landscapes and prey. But something crucial happened in the northern hemisphere during those millennia leading up to the last glacial maximum. The continental climate grew colder, seasons became more extreme, grasslands expanded, forests retreated northward. And across the landscape of North America, a community of megafauna emerged that had no equal anywhere else on Earth. Woolly mammoths migrated across the Arctic steppe. Ground sloths larger than elephants browsed vegetation in what is now the American Southwest. Mastodons roamed the eastern forests. Saber-tooth cats with fangs as long as a man's hand hunted bison and camels in sprawling prides. Dire wolves, heavier and more powerful than modern grizzlies, moved in packs through river valleys and grasslands. Hold on, I need to anchor something important in your mind for just a moment. The reason I'm dwelling on this transition is because it explains everything that comes next. When humans arrived in the Americas roughly 15,000 years ago, they did not encounter a world of gentle giants waiting to be domesticated. They encountered apex predators in an alien world. The complete ecosystem guide to how these creatures hunted, lived, and ultimately fell to human pressure is available in the description and pinned in the comments. It walks through the actual mechanisms of extinction that are still debated today. This is a paid resource, but understanding those mechanisms changes how you see this entire period. Human hunters arriving in this landscape faced a problem their African ancestors had never encountered. The megafauna of North America had never evolved alongside human beings. They had no instinctive fear. They had no learned patterns for what a coordinated group of spear-wielding bipeds might do. A woolly mammoth in Siberia knew to fear a pack of dire wolves because dire wolves had hunted mammoths for hundreds of thousands of years. But a mammoth in North America had no template for understanding a human hunter. That absence of experience proved catastrophic. The earliest evidence of human presence in the Americas comes from sites like Bluefish Caves in Yukon Territory, where stone tool marks on mammoth bones suggest deliberate butchering. Other sites across the continent show similar patterns. Cactus Hill in Virginia, Monte Verde in Chile, Cooper's Ferry in Oregon. Scattered across North America are the fingerprints of human activity, and nearly every significant site shows evidence of megafauna exploitation. What happened over the next 1,000 years remains one of the most intensely debated questions in paleontology. The mammoths were not hunted to extinction overnight. It was slower than that, but also faster than we once believed. Within roughly 1,000 years of sustained human hunting pressure, which sounds long until you realize it represents only 40 human generations, populations of mammoths that numbered in the millions had collapsed to near zero across most of the continent. The mastodons followed. The giant ground sloths diminished. The saber-tooth cats and dire wolves, dependent on the megafauna they hunted, experienced cascading population collapse. Humans were not the only factor in this extinction. Climate change played a role. The warming that followed the last glacial maximum altered vegetation patterns. Some megafauna struggled to adapt, but climate change alone does not explain the pattern. Species that had survived previous climate shifts failed to survive this one. The difference was human presence. What emerges from the fossil record is a picture of human hunters not as mindless killers, but as efficient predators solving a survival problem. They did not need to kill every mammoth. They needed enough mammoths to feed their families through winter. But because they were so effective at locating and killing megafauna, and because those species reproduced slowly, and because their populations were already stressed by climate pressures, the math tipped toward collapse. A female mammoth does not reach breeding age until her teens. She bears a single calf roughly every 4 years. If human hunting removed more calves and females than the population could replace through natural reproduction, the decline became inevitable. The same pressure that had shaped human cognition in Africa, the absolute survival imperative, now worked in the opposite direction. It made humans lethally efficient hunters, even of prey they had never encountered before. The question that haunts every paleontologist who studies this period is simple but unanswerable. Did humans hunt mammoths to extinction, or did they merely finish off populations already dying from climate change? The truth sits somewhere in between, and frankly, that uncertainty is what makes the evidence so compelling. We have kill sites, we have butchered bones, we have stone projectile points embedded in ribs, but we also have warming temperatures, shrinking grasslands, and megafauna populations that were already struggling before the first human spear was thrown. What we can say with confidence is this. When humans arrived in the Americas roughly 15,000 years ago, they entered a landscape of prey animals that had evolved for millions of years without predators shaped by African savannas. Mammoths had no learned fear of bipedal creatures carrying fire and stone weapons. Mastodons browsed forests with no evolutionary memory of coordinated hunting parties. Giant ground sloths, slow and ponderous, had never encountered predators that could think 10 steps ahead. The hunters who walked into this ecosystem possessed something no North American predator had ever developed: the ability to plan collective action, to communicate complex strategies, to track prey across seasons. Those stone tools tell us something crucial about how rapidly human hunting culture adapted to megafauna prey. The earliest Clovis points in North America, dating to around 13,000 years ago, show remarkable standardization. Different groups separated by hundreds of kilometers were crafting nearly identical weapons. This is not accident. This is communication, trade, shared knowledge. Hunters were not reinventing the wheel in isolation. They were learning from each other what worked against what species. Paleontologists have found kill sites where dozens of mammoths were driven into box canyons or bog traps, then systematically slaughtered. Blackwater Draw in New Mexico, Anzick in Montana. These are not scattered incidents. They represent organized hunts involving dozens of people, sophisticated understanding of animal behavior, and logistics that required planning across seasons. One person cannot kill a mammoth, but 50 people with sharp stones and fire and the knowledge of where to wait? That becomes not just possible, but probable. Hold on. I need to pause here because this part gets misunderstood constantly. The extinction of mammoths ground sloths, and most North American megafauna was not a story of moral failure or ancestral cruelty. It was a story of two evolutionary systems colliding. Humans brought tools and intelligence shaped by 3 million years of African predation. Megafauna brought size and strength shaped by millions of years of continent isolation. One system adapted faster. If you want to understand the deeper patterns behind these extinctions, the ecological cascades, the climate dynamics, the game theory of human expansion, my complete guide to Pleistocene extinctions is linked in the description and pinned in the comments. It walks through the mechanisms in detail, the evidence from multiple continents, and what it tells us about human impact on ecosystems even today. The guide goes deeper than I can here. What the record shows us is population decline, not instantaneous extinction. Mammoths did not vanish in a century. The process stretched across centuries and possibly millennia, varying by region and by species. Populations that faced both climate stress and human hunting collapsed fastest. Populations isolated on islands or in refugia sometimes persisted longer. Woolly mammoths survived on Wrangel Island in the Arctic until approximately 4,000 years ago, long after their mainland cousins had vanished. Why? Geographic isolation. No human hunters. No climate-driven habitat loss. The same species lasted 5 times longer when protected from just one of those pressures. This is where the picture becomes clearest. Extinction did not require wholesale slaughter. It required sustained pressure on reproduction. Remove enough breeding females. Remove enough calves. Push populations below a threshold where random variation and disease finish the job. Humans did not need to be perfect killers. They needed to be efficient enough, persistent enough, widespread enough. Those qualities, persistence, efficiency, the ability to scale a technique across a continent, those are what human evolution had been building for millions of years. The mammoths that once numbered in the millions across the grasslands of North America were reduced to scattered herds, then isolated populations, then bones scattered across the tundra. By 10,000 years ago, they were functionally extinct in the lower 48 states. The mastodons, ground sloths, giant beavers, camels, horses, all gone within a few centuries of human arrival. Saber-tooth cats and dire wolves, the apex predators that had shaped this ecosystem, faced a different extinction dynamic. Without megafauna herbivores to hunt, their food sources collapsed. Predators do not last long when prey disappears. What replaced them was silence. A continent that had thundered with the footfalls of giants, that had echoed with roars and bellows and the crack of tusks against bone, became a landscape of smaller animals, deer, elk, bison. These were not weak alternatives. They were adaptable, fast-reproducing species that thrived under human hunting pressure because they could breed faster than they could be killed. The Pleistocene megafauna could not. That reproductive mathematics, that single fundamental difference, determined everything. Human hunters did not wipe mammoths from the earth through malice or waste. They did it through success. Success demanded skill. It demanded organization. It demanded the ability to read a landscape, to anticipate where prey would move, to coordinate with other hunters across distances. These were not simple instincts. They were technologies of the mind, language, memory, the capacity to teach a child not just how to hunt, but why, to pass down accumulated knowledge across generations. The primates who had descended from the trees millions of years ago had finally developed a tool that made them unstoppable. Not a spear, not fire. They had developed an ability to transmit experience itself. By the time early humans reached North America roughly 15,000 years ago, they carried with them thousands of years of accumulated hunting knowledge. They understood animal behavior at a level that would astonish modern wildlife biologists. They read the angle of hoofprints to determine how recently an animal had passed, They understood seasonal migration routes. They knew which predators hunted which prey, and how to use that knowledge to their advantage. A mammoth herd does not flee from a single human the way it flees from a saber-tooth cat, but a coordinated group of hunters moving with intention, cutting off escape routes, driving prey toward cliffs or into swamps. That was a different calculation entirely. The climate was already shifting. Glaciers were retreating. Megafauna populations were contracting. But they could have continued, at least in refuges, at least in protected valleys where the old Pleistocene world persisted. The arrival of human hunters accelerated that ending. It did not create it, but it accelerated it dramatically. Within 1,000 years of human arrival in North America, most of the megafauna were gone. The mammoths, the mastodons, the ground sloths, the saber-tooth cats, the dire wolves, gone. The compression of that loss into such a brief window, geologically speaking, is what marks it as catastrophic. This was not a slow fade. This was a collapse. Before we continue, I need you to understand something fundamental about what we are looking at here. The complete mechanisms behind how predator-prey relationships shifted during this period, how human technology intersected with climate stress, how ecosystems reorganize when their keystone species vanish. All of that is explored in depth in our comprehensive guide available in the description and pinned in the top comment. It is a paid resource, but it is where the actual patterns become visible. Without understanding those patterns, we are just watching dominoes fall without knowing why they were stacked that way. What we do know from the fossil record is precise. The last mammoths on the mainland disappeared around 10,900 years ago. Island populations in the Arctic persisted longer. The smallest mammoths, isolated on Wrangel Island north of Siberia, did not go extinct until roughly 4,000 years ago. They were dwarfed creatures, only half the size of their ancestors, living in a shrinking habitat with fewer and fewer resources. That final population endured for 6,000 years after their mainland cousins had vanished. Then they too were gone. The ground sloths lasted slightly longer in some regions. Megatherium populations in South America persisted until roughly 8,000 years ago. Their extinction was less synchronized than the northern megafauna, more regional, more drawn out. They retreated into caves and remote valleys, becoming increasingly rare, until one day there were none left to retreat. No final mammoth was hunted, no last saber-tooth cat was killed. Most of these animals simply ceased to exist in a way that left no record, a population dwindling to nothing, the last individuals dying of age or starvation in an increasingly hostile world. What they left behind was absence. North American ecosystems had to reorganize around that emptiness. 10,000 years passed, then another 10,000. The continents filled with new life. Bison replaced mammoths, wolves replaced saber-tooth cats, smaller herbivores thrived where giants once fed. Yet something was missing. The ecosystems that emerged were functional, yes, but they were thinner, less diverse in megafauna, less resilient to climate shock. The loss of those creatures changed not just what lived in North America, but how entire landscapes functioned. And humans, the very species that may have hastened the giant's end, inherited a world that was smaller because of it. Early peoples of the Americas developed cultures and technologies adapted to this new, post-megafauna world. They would never hunt mammoths on the scale of their ancestors in Siberia. They would never face the coordinated threat of a dire wolf pack. They developed differently because their prey had vanished. This is the revelation I promised you at the beginning. From tree dweller to ice age hunter, the real story is not just about how our ancestors learned to kill the giants. It is about what happened when they succeeded. When a species, primates who started in African forests, finally gained dominance over the apex predators that had ruled for hundreds of thousands of years, they did not simply take their place in the food chain. They broke the food chain itself. Every innovation that let early humans survive in harsh climates, coordinated hunting, tool making, fire, language, also equipped them to exploit prey faster than prey could reproduce. They were not cruel, they were not evil. They were simply intelligent enough to see that a mammoth contained enough food for a tribe for weeks, and they were desperate enough to pursue that advantage. The giants did not die because humans were superior in strength or speed or teeth. Humans were inferior in every physical way. They died because humans possessed something the Ice Age had never produced before: the ability to plan beyond immediate hunger, to cooperate across generations, to modify the world through technology rather than adaptation. A human child born near the end of the Pleistocene could pick up a spear that its mother had made, learn techniques that its grandmother had taught, and use strategies that its tribe had refined over centuries. The saber-tooth cat could not do this. The mammoth could not do this. The dire wolf could not do this. That is the mechanism. That is why a creature that started by fleeing through branches became the animal that ended the age of giants, not through speed or strength, through memory, through innovation, through the ability to accumulate knowledge and pass it forward. And so the Ice Age ended not with the glacier's retreat, but with the extinction of the creatures that had defined it. Mammoths vanished, ground sloths disappeared, saber-tooth cats fell silent, dire wolves faded into the shadows. The world that had held them for millions of years closed its doors. And in that silence, humans, descendants of primates who once hid in trees to avoid extinction, inherited dominion over an empty continent. Take a moment and consider what this means. Every ecosystem you see in North America today is shaped by an absence. The forests, the grasslands, the distribution of every modern predator and herbivore, it is all a response to a void that opened 10,000 years ago. We are living inside the consequence of that moment when intelligence outpaced instinct, when planning defeated strength, when a species without fangs or claws remade the world through nothing but ingenuity and cooperation. This week, take one moment to walk outside and really look at the land around you. Ask yourself what might be there if the giants had survived. What would the weight of 100 mammoths do to the soil beneath your feet? How would the migration patterns of bison have changed if saber-tooth cats still hunted them? You cannot see extinction, but you can see its shape in the absence of what should be there. Thank you for walking through the Pleistocene with me. If you found yourself captivated by these ancient hunters and hunted, please subscribe so you never miss a new episode. Hit the like button, turn on notifications, and leave a comment telling me which Pleistocene creature you would most want to encounter if you could step back in time. I read every single one!